Hello, hello. Okay. Okay, thank you everyone. Thank you for joining our CPX. So I believe this is the last sessions of our CPX. Okay, hope every guy enjoys. So today I will talk about the HTTPS inspection best practice. Okay, so here's the agenda. First and foremost, so why do we need HTTPS inspection enabled in network security? And second, we talk about the fundamental things about the HTTPS inspections and what kind of improvement we did in the last couple of years. And third is about the survival package. It's talking about something you need to know, otherwise you make some otherwise it will become an issue. And also talk about the performance. We did a lot of performance enhancement after a couple of version upgrade in regard to HTTPS inspections. And finally, I will do a demo how you can configure the HTTPS inspection policy on our network security gateways. Okay, first, so this is happened just a year ago, January. Actually, in Germany, a parliament, they have more than 100 politicians have data leakage. So this data leakage is last for a month, and then the IT security spending of time take few weeks time to identify the issue. So with the issue, we can see that so this victim they don't have enough security measurements like the Gen 5 security, and also the more important is the traffic they can't see because it's all encrypted. So this is the reason why we need to enable HTTPS inspection, because if we don't enable the inspection for HTTPS traffic, basically we have no way to control what can go out and what can come in. So, in the older version, like R77.40, we have some limitation, like a performance, like the way how we match the URL category so that we can enforce the control, like the threat prevention, like the access control, application, and URL filtering. But we did a lot of enhancement since R80.10. So in R80.20, we introduced a new way to the TSL's protocol parser, so that with the new enhancement, we can save up to 60% of CPU cycles. It gives us a huge improvement on performance. We did a test for the with the latest appliance 16,000. We can achieve up to 5 gigabit per second threat prevention throughput with 70% of encrypted traffic. It is a huge improvement. I will show you some of the figure later on when we talk about the performance. In RT.30, we introduced the SNI support. So now we can look into SNI field when the kind hello. When we look in the TS, the first packet, the kind hello, we can look into the SNI field. So with the SNI field, we can look in the domain name of the client want to connect to determine which by this way we can categorize the URL or application the client want to access. It will help us to improve the accuracy about the category matching. And also, we did another enhancement on the internal handling in case the URL or the web or application that the client want to access cannot match with our existing category. So we can improve that to provide better performance, better categorizations. And last but not least, is we also introduced a new streaming engine. This streaming engine, we maximize the performance and also maximize the prevention. With the new packet matching engine, we can inspect the encrypted traffic with our NGTX capability, talking about the access control, including application, URL filtering, IPS, antivirus, anti-bot, and also threat emulation and threat extractions. So another enhancement with the Jumbo Hotfix 107 on top of R80.40. So we now support a scalable URL category. So how we do that? When the gateway receive a hello packet from the client, So we will look into the destination the client want to connect to and query our thread count. So in the older version, we only support one single thread. So each time we can query our thread count one time. So it will create a huge bottleneck in terms of performance. But in R80.40, since Jumbo-Take 107, we now support multi-thread. So multi-query to the thread count at the same time. It depends on the core, number of core in the appliance. So we can support up to 32 threads at the same time. And if you are familiar with our HTTPS inspections, if the way to use it, or if you have an experience to configure it, so previously, since R7730, we have the features called port bypass. So it is enabled. If you want to know how to enable it, you can look at the SK. But it's no longer relevant to R80.40 because we implemented a new way to eliminate the issue, even though the first packet is being dropped for some reason, like the long web browser applications, even though the HTTPS inspection policy, we set it bypass, we drop the packet. But with the port bypass, we overcome the issue. But in R80.30 Jumbo-Take 107, of course, it will be also in R80.40 as well. So we improve the whole mechanism. So okay, so this is the HTTPS inspection policy on R80.40. So there's a couple of enhancements. In the past, we cannot use dynamic object, right? So what you can see here, first of all, we support updatable object. So now, like the screen, you see that there is a Zoom service, a Azure service. You know that for those cloud servers, we don't know the IP address. They always change the IP address. So that we cannot put in a static IP address in the policy to do the enforcement. But now with the updatable object, so for example, in this case, you add Azure service. When Microsoft update the IP list or URI in the database, they have a page to tell the user what is the latest IP address they are using. We get those data. We will put automatic update to the object, and then the gateway, once it's used the object, is no manual effort. Everything is updated automatically. So now we can use it, this kind of object, in the HTTPS inspection policy as well. And also domain object. Sorry. Okay, domain object like Amazon.com. So we can now use the domain object in the HTTPS inspection policy as well. So this is one of the enhancements in R80.40. And you see, this is the rule that we recommend to configure a catch-all rule at the end. Because on the HTTPS inspection, there is it's not kind of enforcement. We don't drop or allow any traffic. The HTTPS inspection policy is only config, do we inspect or bypass the HTTPS traffic. So one is, for example, one is inspect, and then all the content become key attacks, and then we'll start to do enforcement with the firewall, with the application control, or threat prevention policy. But the reason why we suggest to add the bottom rule to allow because if you look at the policy, we define policy with source, destination, URL category. In some case, there is no match for the oral rule. It will become is unclassified traffic. And with this case, we will create performance impact. So we add the policy at the bottom so that if the traffic we cannot match in the previous policy, it will match the last policy. The last policy, you can define that you want to bypass all the traffic that doesn't match in the previous rule, or you can inspect all the traffic that doesn't match the previous rule. It will save a lot of CPU cycle, and will improve the performance as well. So this is talking about more detail about the updatable object. So as I said, the object is created by checkpoint. So everything is updated by our database. So you don't need to configure the IP address or the URI. Everything is done by our cloud services. So what you need to do is just add the object in the policy, in the access control policy, in the HTTPS inspection policies. Just very simple. And here is the HTTPS policy layer. So if you're familiar with R80 versions, so the access control is always there, threat prevention as well. But the TSL inspection is the new layer that allows you to configure HTTPS inspections. So in the past, if you're using the R80.10, 20, or 30, so you need to log into the legacy console to configure HTTPS inspection policy. But now with R80.40, so it's integrated in our new dashboard. So you see the name is a TLS inspection, but we will change it back to HTTPS inspection 1 is GA. Okay. So talking about the fundamentals thing about the inspections. So here's the policy matching mechanism. So anti-spoofing, of course, come first. We look in the IP address. If we come with the interface that we expected. And the second is if you turn on the HTTPS inspection, it will take the second matching way. So in this case, there is a couple of policies that we enabled. For example, we bypass all those financial or government services because in some region, like European community, they have the enforcement that for all those financial services, they cannot inspect and decrypting the data. So, and other thing is like we have the policy to inspect the traffic from the specific source of network for all those HTTPS services. We inspect, and last but not least is the policy to bypass all the traffic that we cannot match in the previous rule. Like what I said, we recommend that you add this rule to catch all the traffic. So after the inspection done, HTTPS inspection done, and then we pass the key attacks packet to the NGTX layer. So including the access control like firewall, application URL filtering, and data protections, and all the threat prevention like IPS, antivirus, anti-bot, and threat emulation and threat extractions. Okay. Okay, so how we can do the TLS inspection. So here's the flow. First of all, when we receive a client hello packet from the client, so we will intercept it, and then the client will use his the gateway. We use his MAC address, but at the same time using the client IP address to make the request to the servers that the client want to access, and we also look into the SNI field with the R80.40 enhancement. Based on the domain name, we will see that the client want to access which domain, and then matching our category. And then once we receive the server hello packet from the server, and then we will look into the CN, the common name, and also other subject fields to match those SNI field to make sure that the client is accessing the web that we first seen from the first packet. Because if you look at the article, there's a way to bypass the SNI. Just manipulate the web browse. Some of our competitors, they just inspect the SNI field. We have the way to bypass the category matching. But this is the pattern technology from Checkpoint. We will look into the SNI field as well as the common name from the server hello, and then to compare it, and then to determine if the categorization is correct. And after that, after the gateway, we receive the certification and do the matching, and then with the gateway internal CA, we will issue a new certificate with the subject of the cloud service that the client want to access, and then the client computer will verify the certification, and then start the communication between the server. And then for those traffic in between, we become key attacks for our NGTX inspections. And one thing you have to know is that the gateway must have the FQDN configured, and also when the client do the DNS query, the FQDN must be resolved. Okay. Okay, so this is the policy. I just recap so that you see the policy in the top is bypassing the financial service, health, government, those kind of category. It's because some region is required, but again, we recommend you to set up the catch-all rule. So it depends you want to bypass all the traffic, or you want to inspect all the traffic. But please set it in the policy at the bottom. Okay. So there's other information. So I know that some of the application now using TLS 1.3, but in the data we can see that it's still a lot. It's over 90% of website or application is still using TLS 1.2. At this moment, even R80.40, we don't support TLS 1.3 inspections. But when we receive the packet from the client, from the SI, we see that is using TLS 1.3 protocol. We will downgrade it to TLS 1.2 to start the communication with the server. So the traffic is still okay. We will not create any interruptions, but we just downgrade the TLS 1.3 to 1.2. In future release, we will support TLS 1.3 as well. But at this moment, we will do the way to downgrade the TLS 1.3 to 1.2 to start the handshake with the server side. Okay. Yep. So okay. Oh, sorry. Go back. So in the URL category, so we have two ways to enforce when we cannot categorize the URL. So one is a block all requests, and another one is a bypass. So as bypass is just let it go, let it pass through the gateway, and block just is easy, just block all the requests. So it depends. The default setting is block all requests, but if you you may want to change it to bypass because it's because if you block all the requests for those category URL that we cannot category, we create the user impact. Just let's use bypass. This is the recommended way. And other thing that you may know that in the for different engine, we have different behavior. For example, in application control, we have the setting called background mode or hold mode. So background mode means when we try to categorize the applications, we still let the packet passing through. So until and then so the connection is still okay, the user can still access the applications. And then once we get all the data from the server side, and then we finish the categorizations, then the next then the second query to the server from the client, we will block it or accept it, depends on the policy. This is the background mode. This is configured by default, but we can also configure to hold mode. Hold mode means even the first packet we will keep on hold in a streaming engine until the categorization is complete. So in this way, the user will feel a certain delay when we access the application because we hold the packet until we finish the categorizations. Okay. So for the threat preventions, the default setting difference. The threat prevention default setting is hold. So we will hold until the categorization, the query from a threat cloud is finished, because it provides maximum preventions. Because even the first packet is malicious, the client access, it will become an impact. So in the threat prevention, we will the default setting is hold mode, and in the future really we will change the hold mode, the name to maximum preventions. Is more relevant to what we are doing. Okay, this is the inspection, the architecture from Checkpoint. So I'm not sure you're familiar with it, the SDN, the firewall workers. So in this slides, you can see that so the SND is the component we use to distribute the traffic to different FW workers. So with Core XL technology, we can leverage multiple core from the appliance to distribute the traffic across different CPU core to inspect the traffic to improve the performance. So in the FW worker, there's a different functionality, including the streaming engine that we order all the fragment packet, and then after the streaming engine, we order all the fragment packet. We pass to protocol parser, like the TLS parser. And then the TLS parser will put the packet in the memory and then the NGTX will start function to inspect the packet that we put in the memory. Okay, survival packet, something you have to know. Okay, so this is the I just said earlier. So the first packet we see in the gateway, since R80.40, we can now look at the domain name field from the SNI field. So with this field, first we can match what the client, where the client want to access, like Facebook, like some other web applications. And then after we receive the domain name from the server hello, by looking at the common name field or other subject field, we start matching from the hello, client hello and server hello, to make sure that the client, when the destination they want to access is matching that from the server side, okay? So that we have a more accurate categorizations, and also we can prevent some kind of bypassing mechanism running on top of the machine. So because some of the user, they may know how to bypass the SNI inspection to allow the client PC to access some other website that's supposing to be blocked. Okay, so this is some of the example, one of the example about SharePoint. So with a wildcard certifications. So in the certification, you can see the common name is SharePoint.com. So that from this certification, we cannot determine what is the actual domain they want to access. So that we need to look in the subject field. Okay, the other field that are inside the certifications to verify the actual location the client want to access, so that we do the categorizations in a more accurate way. Okay, so by default, there is no special configuration is needed to enable the SNI inspections. It's enabled by default. So after you upgrade it to R80.30 or 40, and so and also the as I said, we will compare the client hello, the SNI field, and also the server hello on the common name, so that to provide better categorization. Okay. And this is the log view, if you're familiar with it. So this is the log view without enable the HTTPS inspections. So we have the feature called categorized HTTPS inspections. So with this way, we just look at the SNI field and also the server hello to do the categorization. We don't inspect the whole packet. It will save a lot of performance, but we will also enhance the visibility about the traffic. So in this log view, you can see that without full HTTPS inspection, we can also see that the application the user want to access, like the Google search. When you access Google website, there is a lot of functionality or feature in the web. So that basically you, at the same time, the client induces a lot of different connections. And then with the categorized HTTPS inspections, we can see that the user accessing Google search as well as some other IP category may be a load balancer. And also the protocol is HTTPS over TLS, and some other website provider from Google, maybe Google accounts. Okay. So this is the enhancement I mentioned it about the R80, the Resource Advisor daemon. So this daemon, we use it for different inspection, like the URL filtering, antivirus, anti-bot, and application control widget. So this is the daemon. When the gateway receives the packet, it will query the thread cloud. For example, if the user access www.abc.com, so the gateway will query our thread cloud, www.abc.com, is it, what is the category it belong to, and then after the categorized information come back, then we will enforce it based on the policy. Same as antivirus, anti-bot. So when the user, we find the communication to the destinations, we will query the thread cloud if the site is malicious or if the destination is a CNC server. So we use the R80 to query the thread cloud. In the past, we only support single thread, so that it become a bottleneck. But now, since the R80.40.107 jumbo fix, we can now support up to 32 instances running at the same time. So it's improved a lot on in terms of performance. And it will also integrate in R80.40 by default. Okay, so and also in the R80.30, for as I said, we have the enhancement about the fail mode once we cannot categorize the URL. So this is the configurations in the advanced configuration in the HTTPS inspection. So the fail mode, default setting is fail open. You can change to fail board to increase the security. And for the categorization mode, the default setting in background, so that before we categorize the website, the user still can access the URL. If you change to hold mode, it will hold until the categorization complete. So the section will maintain, but it cannot just open the applications. And for the server validations, so we have 3 options, so that we can drop the traffic. Depends on the certification feedback from the server. For example, we revoke for the revoked server certification, by default we drop it. And also you can drop the traffic if we see that the server cert is untrust or is expired. Okay, default setting is we just drop the revoked server certifications. Okay. So this is the list of trusted certification authorities in our gateway, so that when you log into the smart dashboard, you can see the list. At this moment, this list is updated automatically through our cloud, but we don't provide notifications when it got updated. So, so you want to see the update, you need to log into console, go to this page. You will see that there is an update about the list of the CA authorities. And in future release, we're going to provide a way to notify maybe the administrator when there is an update. Okay, another, this is the config page when you first time enable the HTTPS inspections. I think you guys should be familiar with it. So that the first step you need to do is you need to create a certification with our internal CA, or import a CA cert from your CA server. So if you create the CA cert from our internal CA, and then but the next step you need to deploy the certification to all the clients, so that when the client connect to our gateway, we can accept the traffic to start doing the actual inspections. So another enhancement in R80.30, we provide a CRI tools, so that with the tools you can enable or disable the cipher suite. So some of the legacy cipher is not secure enough, so that we suggest you disable it, because when the client connect to the server side, if the cipher suite we just disable, then we will enforce them to use another cipher suite, maybe using more new cipher suite to have a better security. So that now it is available since R80.30. You can now to select the cipher suite you want to enable or disable it. Okay. In this slide is again talking about some of the recommendations about the unknown traffics. So I think you can know that there's no way to match all the applications. So in some way, especially for the internal applications, there is low signature ready, low categorization ready. So we suggest you to create a policy to accept all the uncategorized unknown traffic or unknown category. So that the reason behind is once we enable this with the detailed logs, so you can look at the log view to see how many unknown applications running inside your environment. So after that, we can start using our application creation tools to create a application signature. And then after the signature created, you can import it to our gateway. Then now you can identify the application which is unknown before. With this way, it keeps improving the visibility, because if you don't have the policy to log all those unknown applications, you will not able to enforce it because you don't know where there's this kind of traffic. So we recommended you to create a policy to at least have a log for those unknown applications, and after you see the log, and then you can start using our application signature creation tools to create a specific signature for those applications. Okay, another thing is about the OCSP. So the OCSP is also another, you need to make sure that in the firewall policy, the application control policy, in fact, you need to accept the OCSP protocol on the policy. Because in some case, when the client browser track the certifications from the server side, if we block the traffic, the application will not work. So make sure you have the policy in the application control rule to accept the traffic from the internal to external with the OCSP protocol. Okay. Okay. So there is a question that can we enforce there's only TLS 1.2 protocol allowing passing through the gateway? There's a way. On our the way you need to do is you create a object, a surface object. Basically, you can just clone our default HTTPS inspection HTTPS object, and then create a new one, and then change the configuration like this. Although the screen is very blue, if you want to know, I can send you the details. With this way, what we can do is we just allow TLS 1.2. Okay. And also we can just allow TLS 1.0, 1.1, or 1.2 by creating a new surface object, HTTPS, and then put it in the firewall policy. In terms of licensing, for the HTTPS inspections, we don't need any specific license for the HTTPS inspections. But in some feature, for example, if you want to do HTTPS inspection for URL filtering, you have to have the URL filtering license. But it's come with the NGTX and NGTP, but not come with the NGFW. So that if you want to use the HTTPS inspection for the URL filtering, so make sure you have URL filtering license. And also for the application control as well, if you want to do HTTPS inspection for application, so you need to have the application control policy. But it's all included in NGFW, NGTP, and NGTX license as well. So talking about the performance. So as I said, we did a lot of improvement since R80.40. This is the performance test we did with 16,000 appliance, the latest model. We use breaking point with the enterprise mix traffic mix, with 70% of 70% of HTTPS traffic. So that from the test, we can achieve up to 5 gigabit per second NGTP throughput. And also, we can maintain 3,000 connections per second. In terms of the CPU loading, it's around 80%. We still have some buffer to handle the traffic spike. Okay. So I will show you the demo to how to configure the HTTPS inspection policy. Okay, so this is the recorded demo. So we are now showing you about the dashboard of R80.40. It's a EA version. So this is the HTTPS inspection policy layer. So this is the firewall layer, asset control layer. This is threat prevention layer. So we now have the new layer called TLS inspection. But later, when it's GA, it will become the HTTPS inspection. Okay, so as I said, we can now using the updatable object. In this case, we use Zoom service, put it as a destinations, and also some other cloud service like Azure service. Okay, so it's just simple. When you want to add other cloud service object, you can click on the source or destination, and then there is a called updatable object. You can just set and then set the object that we created and then put it in the policy. Okay. So this is another object that I mentioned that we now support domain object. So this is Amazon.com. Okay, yeah. This is the new policy layer for DSS inspections. Okay, so any questions? No? So thank you so much. Thank you.